Hello everyone, I am Xiao Gang. In this lesson, we will look at this query. We'll quickly go over it first. Obviously, it is the same as the standard container in other blocks. You can query by number, which is the count saved here. Then, you can check if contents contains this specific element. You can also search using this index method. Correspondingly, such a result. Then you can also do this way. Is our reattachment or these square brackets to return a strong reference or a weak reference, thereby modifying some of its elements with simple modifications. Quite special. It's called, these few items are called FSetElementId. Okay, this is the find, and what it returns is this pointer. Okay, and this can be converted into an array. Okay, well then after quickly reviewing it, we'll go through a simple test sequentially. Let's come back to this place. We'll make this section a little simpler because these contents are actually not very different from the previous ones. So first, we still need a tag like this. Then the area before its tag has already been processed. So here it should not be 8. Just one segment here will be enough. This spot should be equal to 3. Then at this point, it checks if it includes this specific element. Obviously, it has a bladder, but no lemon. Let me click in and take a look at this add. The annotation is the same, right? Look at adding an element to this set. Okay. There are also some other parameter. Is it... Okay. Is this the element that needs to be added? You can pass this type of reference. And whether it is inset, pre-tree, it's just an optional one like this. Is the boolean? Whether this thing already exists. What this means is that it's actually quite simple. Let's click and take a look. It is optional. A is an out to prove that it's the output. It is for you, meaning whether or not it already exists inside here. You can see it here, inside unpassed. It will take this place and use this function, and then pass it in, and then it is, if it already exists, it might then, you can then receive this, which means it will modify your boolean value, whether or not it already exists. Look here, this is how it's done at the underlying level. We can take a look at this ZIN number, right? If this LID set persists, then its value, it means you are not passing a null pointer. You are passing one that has a valid pointer. So this part will do, that is, it will check if there is, that means confirming that this thing exists. Then you need to perform some replacement operations and also inform you that you already have it. And perform a replacement operation. So we can pass a board here. You see, so clearly, we can give a board here. Be already. Let's look up how it already works. Let's write a behavior. This already exists. Somehow, we give a force. So when you actually add it, you can pass this in this place. It will modify this value. If it already exists, it will give a true. Then, clearly, we add it one more time here. Then this value will become true, right? We'll know once we replicate it later. This is continents. If it's continents, it means checking whether or not this element exists. And after the continents check, we can find it using this index. Get its negotiation index. We can perform a simple access using the index. Let us show you. Let's find this at the same time. The promise of this character. Let's standardize it. Okay. Obviously, you can get a thing here. We see. Let's see if there is an index function. Ready, set. Let's check inside set. Index. Let's take a look. Oh, I checked it out. It seems there is no int-agx function anymore. Actually, if you look at find below, actually you can see here, it is here. It doesn't have an index function. In fact, this function, it will return a set ID. So we can actually hook it up here. It doesn't have this index function. You will find that it is empty. Maybe it used to exist. Maybe there were changes in later versions. They removed it. Then this spot is definitely out of bounds because it doesn't exist at all. So we can use this to access it. It's also pretty simple. So how do we access it? Let's add one more here. We'll just add a PPAP here like this. Add the water. We might not be able to find the word. And then here, you can use this thing to connect it. This word, we are right on its elemented. You can obtain this value. And then you access it like this. Actually, if you obtain it, it is this. And then we set it to add equals modify. So actually, demonstrating it here for everyone like this is enough. Actually, you can use this. This is similar to, in fact, to identify an element within this set. You can do it like this, right? We have set these, so let's verify them. Okay, let's start it. I'll set a breakpoint. First, okay, we'll go straight to the breakpoint. We need to declare a TSet here, right? Then we gave false at this location. Obviously, it's still false. It's still false, right? This way, we won't have any issues. So let's pay attention to this part. It turns into true because we already have it. It replaces and wants to go to an object. So that's wrong. And our current count is 3, right? Then we check here if it includes not pulled. Contains not, boolean, whether contains lemon or does not contain lemon. Then we add water. We can get this. The 3 for the FSetElementId. We will make one last simple modification. Let's see. Luckily, it hasn't sucked up enough because we found that this index 3 water modify. It has already been modified by us. Okay, then next, let's continue looking down here. We can ignore this one. This index is gone. There is no such function. You will find the then this place. Sometimes, if we want to determine that it includes a certain value, we are the same as before. You need to ensure that it contains. Then you can use this operator to perform. Go make an access like this. You need to check once here if it contains this element, and then access it. Then you need to perform 2 successful lookups. So the final variable can do a single lookup. If it can be found of, it will directly return a pointer pointing to this element, and if there isn't any, then give it an empty one. Then you can go to, that is, if it is a constant, what you return might be a constant that cannot be modified. Here, let's look for this pointer to see if we can get this pointer. And the 2a is equivalent to, it converts it into an array. We can take a quick look at this. We can see that it's here. Let's go inside. We find this element here by providing this k value. Actually, right, there are actually many other ways for this. Those find by hash. Or if we go up and some open methods like this, and some actual M06-004 actually, this method is also the same. It means ensuring that you will definitely have such an element. If it exists, we give you a ready one, right? He will add a FindOrAdd for you. That's what I mean. Okay, everyone who needs it can look below. Is something like this empty? The largest index means it has the maximum index, right? This number count. We will discuss the compression of this share later. You can just clear it. Similar ideas, approaches. We just need to verify these two. Okay, as for this comment, we can delete it because it might be different. And then we set it here to link 32a equals, and then let's run it again. Let's take a look at the result of this execution. Okay, our breakpoint has been reached. Let's mainly look at this find. Look, it's a pointer. It points to some of these byliners. It points to this byliner in the set, and it is empty, proving that this object does not exist, not found. Then at this place, it actually converted into the host of this TArray. You can see that an array returns a host inside it, and then load this element onto it. Then it will first perform a reverse on this host. Let's take a look. It should keep this host. There should be at least this many elements. I think it means this. Then he goes and adds it to our set. Okay. The data passed here will be cleared before being filled in. We might need to verify this spot, because, take a look, it doesn't seem to perform this release action. I think there might be some issues. Let's write some code here to verify it. So, let's have the data randomly add some things. Oh, no problem. I misunderstood this part. It's like this. He will directly give a host. Actually, the host he gives is the host for life in this plate. In fact, he takes this host and directly copies it into this host. Instead of having you pass a host to modify, you'll notice that it doesn't pass parameters. It directly gives you a host, right? So this host, so this isn't called a passed host. It is cleared before filling it in. That statement is incorrect. This isn't right. It actually takes a new host and copies it to an old host. Then, no matter what the previous old host, whether it has anything, it will be completely overridden directly because it directly copies this thing over. The real host is generated in this place. So understanding it this way is correct. Okay, so for this simple query in our class, we'll stop the explanation here. We went pretty fast, much faster than before. You can also tell that